Hello and welcome to another tutorial. So this time around we are going to be kicking off the first in what is going to be a series of tutorials looking at creating more sim style AI. So we'll dive straight on in. So I've already actually set up a bunch of things in this. So the starting point that I've got for this, it's using a pared down version of the sort of little character controller. This is a very basic one that's able to move around the world using Unity Nav Mesh. So I've already built the Nav Mesh. I've also brought in, these are some objects I built using Cubicle and just textured those. So these are ones that if you're wanting to use them in your own project, like with any of the code with this, it's fully available for you to be using it in any of your own projects. So I've just done a little bit of texturing of those, or flat coloring of them, and a little bit of sneaky stuff because their tables are a little bit too big, and so just making them a bit more reasonable size. So the focus on this is going to be setting up sim style AI. So one of the core loops that happens in the sims is we have objects in the world and the sims interact with those objects either because we have told them to or because they have chosen to perform an interaction there. And the sims look quite intelligent. You know, they're hungry, they'll go and get food. They'll, different things, they'll go and do different actions there that look really quite intelligent. One of the things that is great about the sims and what I love is a lot of the logic isn't actually on the sim. A lot of the logic is on the objects in the world. So the fridge, for example, that's in the world, that fridge is constantly advertising and saying, hey, I can allow you to perform this action. So it might be grab leftovers. I can allow you to cook breakfast. I can allow you to, cook a quick meal or something like that. It advertises the interactions that are possible. And then what the sim does is the sim looks essentially at this room full of things that are just holding up signs saying, I can do this, I can do this, I can do this. And it looks at all of them and it says, okay, well, if I did that, here's how it would improve my overall sort of happiness. If I did this, here's how it would improve it. So it does that calculation for everything. And then it works out, sorts those, and then picks from that range of ones. So a lot of the logic sits on the actual objects. The objects define what the interactions are. They define sort of the general effect of like this satisfies this amount of hunger, this satisfies this amount of fun. They describe stuff like the time that it will take. They'll also often include things like the visual and audio effects there. So what that means is that you can easily, and it makes a lot of sense, it's a really clever way of designing it because it means you can then add in a new object and those interactions could be anything and it will just work. You don't need to go and change a lot of how the sim works unless you're doing something really, really, really out of left field. So it's a really great way of doing it. So what we're going to focus on in this first part is getting that system set up so that objects can advertise different sets of interactions that can be performed with them, and so that the AI can go and perform those interactions. Now, we're not going to make it pick a particular interaction in an intelligent manner at this stage. We're going to focus on just it being able to select one and to perform that. That's going to be the focus that we have to begin with. So let's get this set up. If we think about what we need a way for the objects to have an interaction. So let's start putting together the pieces for this. So I'm going to create a folder. I'm going to call systems, and I'm going to call this smart objects. And then we'll get our script set up. So, okay, objects, we're going to obviously have a smart object. So that's going to be the container thing that's going to do a bunch of the wrangling there. So we need to have a smart object. We're going to need something that the AI can talk to find out, well, what are the sort of smart objects that are around? So we're going to have a smart object manager. So that's what the AI will be able to talk to. So we'll set this up as, this will be a empty game object that we'll attach the script onto, and we'll just call smart object manager. So the smart objects will talk to it. So the smart objects are also going to need a bunch of interactions that can be performed. So what I want to have, now with these, there's only going to be sort of initially very simple interactions. So we might have an interaction that can always be performed. We also might have an interaction that maybe is linked to a resource or that can only be performed a limited number of times. So there's going to be different types of interactions. So this is where I want to set up inheritance. So I'm going to have an interaction, I'll call it base interaction. And then I will have just an initial one that is based off of that, which will just be simple interaction. We might call it interaction simple. No, we'll go for simple interaction. Naming things is always tricky. So, okay, let's start to set up the different things here. So, smart object, let's think of the stuff it's going to need. So smart object is going to need a list of interactions. But the way I want that to work is I want to just be able to attach a whole bunch of different interaction scripts on it. So what I'm going to do for the smart object is I'm going to have a protected list of base interactions. This will be cased interactions, which will be null. And then I'm going to set up a property here that what it will do, we'll call it interactions, is in the get, well, if cached interactions is null, then I want interactions to be a new list, which I'm going to populate that with. We do get components, and we're going to retrieve anything that's based off of base interaction. So this will just make it that we've got that all sort of set up. So that's cached interactions. Need to make sure we have the naming right. And then we can just return that. We won't have a setter for it. So that means other things can very easily just sort of access and find that. So that's good. Smart object, we should assume that these are going to need to have a visible name. So serialize field, make a protected string display name, because this then allows me to have, in case I need it, a display name that maps to that. So that looks pretty good. So this will populate the interactions based upon what's attached to it. That will then mean in start, we'll be able to register ourselves with the Smart Object Manager. So that's the other thing. Smart Object Manager needs to be able to be told, hey, here's an object, here's the interactions. And that's the sort of initial stuff we're going to get set up. So, okay, that means I want to be able to easily access this. So singleton is my go-to method for that. So what I'm going to have is will be a public static Smart Object Manager instance, but it's a private setter. Then in awake, I will set that up. So we'll do our general checks first. If instance is not equal to null, that means we've already got there's a pre-existing copy of this, and that shouldn't happen. So I'd always throw an error, trying to create. And we just log out the game object name so we can easily find it. We then destroy the game object and return so we don't create any other duplicates. and we just populate the instance. So that's good. Now, Smart Object Manager is going to need to be able to register the set of interactions. So, okay, we are going to have this have a register smart object function. So the public void register smart object, and we just provide the smart object. So to register, and we'll also, because good to make sure we can clean up if we need to, we'll have a deregister smart object. To deregister. So the idea being then, a smart object in the start function can just go and say, well, okay, hey, smart object manager, instance, register this. We can also then set up an onDestroy, where we'll do similar sort of thing, but we do a deregister. So, okay, that's the lifecycle side of that going. Smart Object Manager, well, we want it to maintain a set of these, and we want it to be a set that we can easily query if we need to. So for now, I'm going to have this as protected. So I don't know if I need or want to give direct access to this to other things. So my default in a case like that, where I'm not sure if I would need to give direct access, is I'll usually start with it being protected or private. That's usually my go-to in that case. Actually, that can be private. We wouldn't inherit from this. So private dictionary smart object, and can have a list of the interactions. So base interaction. Now this is assuming that for an object, so this is making an assumption that for an object the set of interactions doesn't change. So this is an important thing for us to consider at this point. Would the set of interactions change at any point in time? And they might. We might want to have something where we upgrade it. So that is a case where, to save potentially regenerating that, I'm actually just going to keep a track of the smart objects. Registered objects. And we'll have them all registered, and then here we can do add to register, and then here we can do a remove. So good so far. That's pretty much the key bits of life cycle for that. Now we can actually, and this is actually then a case where I would make that then public. Still keep it that it is a private set, but allow other things to access it, because I think that's quite reasonable. So, okay, good so far. Well, now we can start thinking about getting our interactions set up. So the base interaction, I want to be able to enforce some rules of what functions need to be there. I also want to potentially be able to have some specific functions and data there. So because I have that combination where I want to have some predefined data, I want to mandate some functions that have to exist, my best option is to actually make this abstract. So I can make that abstract. And if we think about the kinds of things that we want, so any interaction, it should have a name. So we'll have do similar to what we did before, protected string display name. And then down here, we can do that. So we want our display name. We want also an interaction could take time. But we also might want to have ones where it's a bit of a type there in terms of that regard. So I think it would be good to have interaction type. So I think that's one where we can, indicate, okay, instantaneous. And I'm giving these initial values just because that's something that really handy to do later on if we need to add in extra ones. So I'm going to say instantaneous or over time. Now there might be other things we have beyond that. And I mean, we also have the class inheritance that we're doing, but I think this is just good to have that set up there with this. So we'll have our interaction type. By default, we can make it that those are instantaneous. And again, similar sort of thing here, which autocomplete is helping us out. I then want to, just for the fact that we will have potentially time values there, we'll have float duration, which we'll set initially at 0. So if you set over time with 0, we'd still effectively do the same thing. Set up our publicly accessible one. So, okay, we've got a name, we've got the interaction type, we've got the duration. Stuff like effects, we would be adding at a later point. For now, just want to be able to make sure that we've got the different ones there. Now, in terms of functions that we want to have available, so I think a definite one, because an interaction might not always be accessible. So, can perform, I think, is a good one to have. So we have a clear indication that that is wanting to be performed. Abstract. We also, if we think about an AI, there's different levels of interacting with it. There is, I have decided to go and perform this. There is, I am now there and performing it. And there is, I am done performing it. Now, it might be something that only one AI could perform at that point in time. So if someone's already performing it, that's something we want to know. So repair. Let's call it actually lock interaction. So when an AI heads towards it, it will lock it. When it's done, it will unlock it. And when it's there to actually perform it, perform. So these will be the key ones that we need to set up. So can perform will just be a simple yes, no. Lock interaction will be what we set when we're on our way to it. Perform will be what we set when we get there. And unlock will be what we set when we are done with it or if we picked a new thing to head towards. So that's good. That means we can now set up our simple interaction, which this is going to inherit from base interaction. Now immediately means there will be a bunch of things that we have not implemented, which is fine. So this is stuff where we can then add these in, which we can just generate the overrides. We don't need to generate all of the different ones. So it just gives us our basic ones, which is good. So we're going to say that it can always be performed at the moment, though what we could do is simple interaction. Could have serialized field protected int max simultaneous users might be 1. And then that's something where I won't make that public at this stage. We'll keep it like, we'll go for that. So can perform. Well, we want to keep track of our current users. Num current users, 0. So then can perform, we can perform it if num current users is less than max simultaneous users. When we go to lock it, we update the number of current users. When we go to unlock it, we do that, but I'm also first going to put in a check of f num current users is less than or equal to 0. I'm going to unlock an already unlocked interaction. Just to be sure, because it's best to be safe with that, because that's something that definitely should not happen. Now perform, well, perform needs to check. Okay, well, firstly, I'm going to do a check of f num current users, again, is less than or equal to 0. Then what I will do is there will be a return, but again, debug log error, trying to perform an action when there are no users. So good to just make sure you get these sort of error logs in early, because these are scenarios that shouldn't happen, and it's best just to have safety checks in there. This is one where I would also then check in if num current user is greater than max simultaneous. Too many users have locked this interaction. And we'll output the display name. So we'll just make it easier to find if something goes wrong. And this is an important thing. Get the error logging, the error checks, things like that in early, so that when something goes wrong, you don't then have to go and add them in afterwards. Get them in at the beginning when you're writing the stuff, when it's clear the potential things that could go wrong. So perform, well, this needs to check if this is something that runs over time. So if interaction type is instantaneous, then what we do in that case is, well, we perform it. Now, perform, probably it'll need to actually notify something. So with performing the event, it's a little bit more complex than it initially looks like. The reason being is that we could, and we're specifically wanting to support multiple things performing an event simultaneously, or an interaction simultaneously. So that means when we do perform, we actually need to know who the performer is, which actually we could make that a game object or mono behavior. Either one actually would work, but something to keep track of who the current thing performing it is. We also want to know when it's complete. So that's where having a Unity event, so I'm going to bring in using Unity engine.events. We'll set up so we have a Unity event that can pass back the base interaction, but we'll make that by default. It can be null. So we need to update over here, which also means bringing in using Unity engine.events. So, okay, that's good. But what we then do here is, if it's an instantaneous one, it's quite straightforward. So if onCompleted is not null, we do onCompleted invoke with this. So pick the interaction type. Now, if it is a timed one, so if the interaction type is over time, then what we need to do is, if we have an onCompleted, we actually need to keep track of that progress. So actually, given that context, I'm going to make it that onCompleted is not optional. I'm going to make it mandatory. seemed like reasonable to have it optional, but I actually think given that stuff could happen over time and we want to make sure things properly deregister, I think it makes sense to have it have to have an on completed. So, okay, when we do this, we need to somehow be keeping track of these. So let's set up, and because we need to know the sort of time they started. So we're going to have a protected dictionary. The key for this is going to be a mono behavior. And then we need to have our sort of performer data. So what I'm going to have is a protected class performer info. So it's going to have a public float of the start time, so when they started doing that interaction, or actually, let's call it interaction time elapsed, or elapsed time. We'll also have our unity event for the base interaction for the onCompleted handler. So then performer info, we're going to actually probably can just have a list of those. I think we'll be fine. So current performers, easy enough to change it to a dictionary. I often use both, so I think just actually having this will work. So current performers. So when we're doing this, we're going to add new performer info, and we can just populate the things. So elapsed time will be 0, and onCompleted is onCompleted. What that then means is we can have our update function. So we'll have protected virtual void update. We want to check if we've got any performers. So update any current performers. Going to use just a regular indexed for loop. So index is 0, index is less than our current performers dot count. Like that, we grab our current performer. So then what we would do is, I'll just call that performer. So we update the elapsed time. So performer elapsed time, that needs to have typo fixed. So elapsed time, we update the delta time. Then we check, well, if elapsed time is greater than or equal to our interaction time. So that was our duration. So if it's greater than or equal to our duration, then what we would do is performer onCompleted. We can invoke that. Interaction complete. And then what we also are going to then do is current performers remove at that index, and we do minus index, or what we do is we traverse this list in reverse order. So index is that, index is greater than or equal to 0, and then we do a minus. Saves us having to do juggling of the index down here. So that's going to allow us to have multiple performers. That's going to allow us to keep track of that stuff quite nicely. So that looks pretty good. That's genuinely a lot of the logic that we actually need now up and running. So, okay, let's start to set up some of these smart objects. Let's start to give a bunch of these capabilities. So I'm going to go to the prefabs for these. So let's start with the bookshelf, for example. So I'm going to add in a smart object, bookshelf. We can then add in simple interaction, which might be browse. Runs over time. We might say that that is a duration of 5 seconds. And at most, 2 people could browse a bookshelf. So really quick to set these interactions up. Let's set up a couple of other ones. We've got our TV. So we'll set up a smart object. We'll set up an interaction. And we might make that, it's an instantaneous one. Change channel. TV. Only one simultaneous user. So, okay, that's good. Let's check that things are actually registering. So in our Smart Object Manager, debug log, to register, display name. Just so we know things are getting registered. Because once they are, then our AI is just going to pick things and perform that interaction. So we can see bookshelf, TV, both bookshelves registered, which is great. So, okay. Now it's over to the AI. We want it to pick an object and pick an interaction, and then perform that. Once it's done, it'll pick another one. So at the moment, we've got reasonably simple setup on this. So I'm going to set up under here with scripts. I'm going to call this is going to be the overall sort of controlling one for the AI. This is going to be, let's call this, it's always hard to name things like this. Not really a simple AI, but I'm going to call it simple AI. Although I guess the logic that it's doing is actually quite simple, so it's not necessarily inaccurate. So what it's going to do, so simple AI needs to be aware of our navigation system. So that's going to be one of the things. It's going to require component. It won't be a camera, but it will be the navigation. That way it can tell it to go to locations. So it's going to need a protected navigation, which I'll populate that in awake. So, okay, what it needs to do is let's write the thing for picking an interaction. Void pick random interaction. Well, it can go to the Smart Object Manager. So Smart Object Manager dot instance, and has on the Smart Object Manager, we have our registered objects. So I just want to pick a random object to start with. I could also pick a random one that has something valid, but let's just go and pick a random object to start off with. So random registered objects, and we're going to go and say that, well, we need to pick a random index. So int index random range from 0 to count. We grab that random one, selected object, pick a random object, and then pick a random interaction. So selected object, and we have a list of interactions. So again, I'm going to rename that to object index. We'll pick a interaction index. So selected interaction, and we'll say our interaction index is going to be similar approach to what we did for picking the random object. So random range, 0 to our selected object, interactions count. So, okay, we've picked a random interaction. Well, let's check that we can actually perform that. So we've selected interaction can perform. Then what we're going to do up here is we will have a protected base interaction, current interaction. So first thing we'll do is we will set that to our selected one. We're going to tell this one that we are wanting to perform it, so we're going to lock it. And then we're going to tell the navigation system to set your destination to this new one. So we're going to head to current interaction, transform position. That could also be something where we ask the interaction or the smart object for the location to head to. It'd be very easy to do that. We're going to check if that failed. So debug log error, could not move to, and we just provide the selected object name just to be clear with that. And if that was the case, then we'll also set current interaction to null and we'll exit. We can perform the interaction. Move to the target. We actually won't need the return. So an update then, well, if we have current interaction is not equal to null, and if we are at the destination, then what we want to do is current interaction perform. We are the performer, and we need to give it an onCompleted function. So we'll have a void on interaction finished, and that will look like that. So when it's at the destination, we want to tell it to perform it. So we've set up our interaction finish function, but when we put that in, we'll actually get an error. And that's because I always forget between the difference between Unity event and Unity action. This is a case where I should, all of these ones that I had Unity event, I actually meant to have Unity action. So I just change those locations where I had that, including in the base one. And then what I will find is that will actually then happily bind to that function. So, okay, when it goes to perform it, this will let us know that it's finished. So then we want to go interaction, unlock, so that we are done with it. And we'll also then go current interaction is null. So that looks pretty good. We want to set up so that this can also have a time delay between picking things. So I'm going to set up serialize field, protected float, pick interaction interval, and we might say every 2 seconds. So then we'll have a protected float time until next interaction picked, which will default to below 0. So in this case, this then changes a little bit to, well, if we're at the destination, because if we don't have a current interaction, then what we want to do is, okay, well, our time until next interaction picked. We update that. Then, if that is less than or equal to 0, we're going to go pick random interaction. And what we will also do is, because we don't want it thrashing every frame if it failed to pick, so we're going to reset that interval there. So I'm going to pick an interaction, and then we'll check in a couple of bits of debug displays, else debug log going to, and then we can say current interaction display name at selected object dot display name. Then we can say here debug log finished display name. So that should work. This should pick a location. Now we might need to adjust things like the thresholds for saying that we are at the destination. That's something that is very possible that we might need to update, because we'll take a look and see for the AI currently, its destination reach threshold is quite small. So it's something that we might need to make that larger, or we might need to set up stuff where it's easier for it to access that. So let's run this and see what we get. It's going to run, so it's going to browse at the bookshelf. Now, with browsing at the bookshelf there, likely what it is it's a case of it has not gotten close enough to think that it is at the destination. That's quite likely. So a handy thing for each of these objects would be essentially giving them a marker. So we're going to take our smart objects and we're going to give them and we might actually make this public. Actually, no, we'll go for serialized field, same process we did for the other stuff. Serialized field, protected, transform, and we'll call this interaction marker. So then here we can then say, okay, well, we'll have public transform interaction marker, and what we'll do is we'll make this a little bit smarter. We'll actually make that vector 3 interaction point, and we could then make this so that, well, if interaction marker is not equal to null, then we use interaction marker's position. Otherwise, we just use our position. So it gives something that's a nice sort of safe fallback. That then means the simple AI, when it's going to do the navigation, so when it's setting that destination, we would actually set it to selected object, interaction point, and then we can go and update these objects. We can set up, if we go to the prefabs for these, so let's pick the bookshelf. So what I'm going to do is I'm just going to add, and I'll initially make it so I've got a sphere there so I can easily see it. I'm just going to position it probably about 1 meter out, should be sufficient. So interaction point, and then going to get rid of everything else on it because I've made sure it's at the right spot. And we can just link that up. So we've now got our interaction marker. Now the TV is a little bit more of a complicated one because it is going to be a bit up in the air, but that should actually be okay. So again, create an empty interaction marker, because I know the pivot point. This time I won't worry about actually setting it. So this, that interaction marker, we might make that 1 meter away. Link that up. And let's see how that goes. So it's again going to browse the bookshelf. It should hopefully have actually reached it. And it did. Now, we did see we got a couple of errors. And if we look and see what sort of happened, it finished the browse. So we got that message from the AI that it had finished. And we nulled out the interaction. We should actually, that's fine. But we then got that it was trying to unlock one that was already locked. So that we want to just double check and see. And it got that quite a few times. So it did receive that quite a few times. And what may have happened is it may not have removed it as something that was able to be performed. So we just want to go and double check what's happening with that. And in particular, what we're going to do is we're going to put a breakpoint in the unlocking, and we're going to put a breakpoint in the interaction finished. Just to make sure that we haven't missed something that's causing it to be run multiple times, which can happen. So it's going over to the bookshelf. We'll wait, we'll get it, it will finish. So it has finished. So it said that. We step into this, num current users is correct. So that's good, that updates. That should also mean current performers. So we can see the issue we've got here. Current performers it's run that perform far too many times. So now we know where we've got a problem happening. So that gives us a different set of stuff to look at. So we know it ended up with perform being run way too many times. So we just want to see what's actually happened there. And what it would likely be is because we're at the destination. Yeah, so at the destination is going to be true the entire time we're there. So what we're going to do is have a detected dual started performing is false. And whenever we successfully pick one, we're going to set that to false. Then up here, we check, and we have not started performing. Then we set it to true. We do like of that. What that should now mean is that we don't get that spam of errors. It's not going to get there and go, okay, I'm going to perform this, and I'm going to perform this and this. So there we go. Change the TV channel. Going over now to the bookshelf. So it means that then interactions are really quick and easy for us to set up. We've got our basic sort of stuff there. Let's make the interactions a little bit more complicated. So, and this will show sort of the ability for us to really extend these. So the interactions, I'm going to change the one on the TV in a bit so that it's just an on-off, and change channel. You can only do that if the TV is actually on. So let's go for a simple setup here where TV interaction, change channel. So this is going to be based off of the simple interaction. Simple interaction. Now it's going to need to be able to talk to that TV. So I'm going to have a different version of the smart object that is based upon that the TV will use instead. So we're going to have a smart object TV. This just illustrates sort of the level of customization we might need to do. So smart object TV, it's going to be based off of smart object. We're going to have a public bool is on, get, and make it still a protected set is false. So the idea being then that this is something we'll be able to toggle. Toggle state is on is now equal to the opposite of that. So then our change channel one, well, what it's going to need is it's going to need to know the smart object that it's linked to. So this is going to require type of and our TV. It's going to need to keep track of that. So linked TV. Then we override the can perform, and it also requires, so it requires the base can perform and link TV is on. So it can only go and turn it on if the actual TV is on. So that's good. We also then, interaction-wise, we need to change it. So our TV interaction, toggle power. So then toggle power, this is going to be very similar to our change channel. So to the extent where I'm going to actually lift a bunch of the stuff from this. So it's going to be based off of our simple interaction. It's going to, much like this, have a linked TV, which we do need to populate that. So I'm pretty sure the interactions don't override awake in any regard. So we'll have a protected void awake. Grab the link TV. So bring this over for the toggle power one as well. And then this will override the perform. So I'll have a public override void perform. Can still run all of the base one, but what we will do is we'll say linked TV toggle state. So we'll be able to turn the TV off and on. So fairly simple set of ones, but it will change quite significantly the behavior for the TV. But really quick for us to set up. So we go to our TV then, and what we're going to do is bring over the smart object TV. And we'll just open this up so we can easily link up that. So we have TV. We get rid of these interactions because they don't apply anymore. And we add in toggle power. And we add in change channel. So that should change what things it is able to do with the TV. So it shouldn't be able to change the channel unless the TV is on. And so then we'll have a debug log. TV is now F on, otherwise off. If we run this, what we should see is it can do a change channel, but only when the TV is actually on. So it's going to go browse the bookshelf. And somewhere, if I wanted to, I could just turn off like the bookshelf, so it has to interact with the TV. see if it picks the TV next. If it doesn't, I'll turn off the bookshelves. Okay, they really just want to read a lot. So we're going to turn off the bookshelves so that it has to interact with the TV. So it's going to toggle the power at the TV. So it finished doing that. Now it can change the channel. So it's now turned the TV off. So the only interactions it can then do is toggling the power. So we have a setup now where we've got a little bit of state information being tracked there. So what the interactions they do can affect the actual object itself, which then affects other interactions that are possible. Which this gives us now a really solid basis for this, because this is now something where what we'll be able to do next time is start to factor in, okay, what is the effect of doing this interaction? How does it affect our mood? How do we decide and score which one to actually perform? But this gives us our basis. So look at setting up some other things. You grab this code. We've got some basic interactions there. We've got a few examples of how we can extend that. So dive on in and see the kinds of things that you can be doing with that to sort of extend it and make some more cool stuff there. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciated. If you've got any questions, chuck in a comment below. If there's other things you'd like to see in videos, chuck those in as well. And if you're looking for the code for the project, that is available up on GitHub. Code can be freely used in any of your own projects, commercial or non-commercial ones. You're able to be using that there. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below. But until next time, bye.